Okay, so now if you observe closely, your PCB has a lot of text which gives you information about the components which are being placed on the PCB. So let's say, for example, talk about this input filter capacitor over here. Now there are two things which describe the capacitor. First one being C1, which is the designator of the capacitor, and the second thing being the value of the capacitor, which is 10 microfarads. Now this is text which is being printed on the top layer of the PCB, and to be more specific, it would be printed on the top silk screen layer of the PCB. And if you see right now, the text of the C2 capacitor is being overlapped, and that's happening almost everywhere. Like if you noticed, the size and the font, even the font types are different. So we want a single font style with a single font size and with a single font thickness. So for that, I can manually change the font size and all those parameters, but that would be too long of a procedure. But let's say I'll show you how to do that. But to begin with, let's talk with the capacitor. I'm gonna just right click on the origin of this designator and go do properties. So the size is 1.27. The font type is proportional, and Eagle offers three font types. For simplicity, we'll just keep it proportional, and the ratio is 10%. I believe this is the ratio of size to thickness, and the layer is on the T names, which is the top names layer. Similarly, there is B names, there is T values, and there is B values. So we'll just keep it on T names. If we come to the value of this capacitor, it has to be on the T values layer. But if we come to this reset switch and do a right click on the designator and go to properties, the font style is vector, which I'm going to change to proportional, and the ratio 10%, and just hit apply, and you can see it changes. I'm going to quickly do the same. So I'm just going to change the font size and the ratio. And here we go. All the components now have the same font but different sizes. For that, it would take too much time if we manually select each and every manually edit each and every value and designator and update the size. For that, we have a thing called as ULP, which stands for I believe user language program. These are basically automation scripts written by Eagle or some third-party users which automate a hell lot of stuff for you. Now I'm just going to click on ULP button on the top over here, and these are all the ULP scripts which are available to you. There's a ULP script which exports a bill of material, which changes pad sizes, VIA sizes, and whatnot. I'm going to scroll down and select normalize dash text, which normalizes silk screen text sizes. But there is an improved version of this one which is called as normalized text 2, I believe, and I've already downloaded it. You can just Google for normalized dash text 2 underscore 0 ULP. So I'm just going to browse in my documents Eagle subdirectory, and I'm going to select this and click on open. Now this thing opens up a window, a dialog box which says normalized text sizes 2.0. These are the names of the authors, I believe, who wrote this ULP. Now output units, let's stay in millimeters. Text size 1 and text thickness 0.1, which gives us a ratio of 10%. And this, if I hit normalize, all the text will be changed to this size and this thickness on these layers. So layers to change separated by spaces. So we are going to change the layers to begin with, let's see, 21 T place, which is like the placing of the components layer, B place, T names, B names, T values, V values, and also 121 and 122, which is the top silk screen layer and the bottom silk screen layer, which we will get into pretty soon. So I'm just going to hit normalize, and this is a list of commands which Eagle is going to execute for us, but the script has already been written. So I'm just going to hit execute. And now you can see all the components are of all the fonts are of equal sizes. Now the next thing left to do is properly arrange all the designator and the values probably next to each other or on top and bottom, so that everything looks visually clean. So let's say somebody else who has not designed this PCB has to solder these components. He or she should know that 7805 should be placed in these three holes because it says U1 and 7805. Similarly, I'm just going to do 10 microfarads over here and 10 microfarads over here and do C2, and I'm going to repeat this for each and every component. There is one more thing which can be done, or rather which needs to be done, is adding text in front of the pin. Now the text you are seeing over here which says D9, that's just Eagle telling you that the name of this net which goes from the pin 15 of the IC to pin number 1 of JP2 is D9. So that's just the name of the net, but we need to explicitly specify that this pin number 1 over here is digital P9, so that it gets printed by the PCB manufacturer prints it on the top cell screen layer. How to do that? That's very easy. All you have to do is go to the text tool, hit D9, just type in D9 and hit enter. Now make sure we are on the layer 121 underscore T silk. That's the top silk screen layer. Size, I'm keeping it as 0.8128 ratio, and you can also change the font and do vector, which kind of also looks cool, but let's do proportional, and I'll just place it. And you need to do the rest, do the same for all the rest of the pins. What you can also do is add some more text, like this is port B, pin number X, and it's also PWM, that sort of helpful text which helps in prototyping. That's it. So I'll just do that for the rest of the pins and get back. All right, so here we are. Let me zoom in and show you what I've done. So I've added the names of the pins next to the jumpers. Say D9 is port B pin 1, D11 is port B pin 3, and acts as the MOSI pin of the SPI protocol. And I've done the same for all the rest of the pins. I've also added my identity. I've also added the name of the board, the version, and the date at which we are doing designing this. And I've also added some text which says input voltage 7 volts to 16 volts. Since it's in 7805, you need at least 7 volts for this to operate. And the fuse over here has a maximum rating of 16 volts. That's why the input voltage rating of this circuit is 7 volts to 16 volts. Now it doesn't matter for 7805. As per the data sheet, the input voltage can go up to 35 volts or 40 volts, but since the fuse is rated at 16 volts, our input has to be under 16 volts. So that looks like a clean PCB as of now. Now the next step is to generate Gerber files. Now Gerber files are something which are required by the manufacturer to manufacture the PCB, as simple as that. Now, and these Gerber files need to be zipped and sent for the manufacturer to the manufacturer. So let's get started with that. Okay, so the first step you need to do to generate your Gerber files is click on the CAM processor button on the top left, and it opens the CAM processor window. Now Eagle deals with what we call .cam files, and we're gonna there's already a cam file loaded which says template underscore 2 underscore layer dot cam, which will generate all these output files. But let's open a particular cam file that I need to go in my C drive, Eagle 9.4.2, and then I'll be going somewhere in examples. Yes, I'm right. We have to do in examples and then cam files, then examples. Now these are all the example 1 layer, 2 layer, and all up to 16 layer cam files. But let's go ahead with third party and go with OSPark. And in OSPark, there's an OSPark 2 layer cam file. Let's open that. Now the whole layout of the output file changes, as you can see. Now this is an OSPark cam file for 2 layers. We don't want our Gerbers to be generated for 2 layers. We just want our Gerbers to be generated for 1 layer. Okay, so let's select the files and the layers according to these output files. So under Gerber, there's a board outline selection, which will select the outline of your board, and these are the layers in Eagle which which needs to be selected. So let's say I can add these layers. Let's say I had made the dimension of the board, like the boundary of the board in the dimension layer. So I'll just select 20 and click OK. Although there is already a layer loaded just as a backup. Next, top solder paste. We are not soldering any components on the top layer, so I'm just going to select this and click on the minus button over here. So that deletes. One of the favorite layers, top silk screen. So as you can see, these are the symbols and let's say the outline of the register and IC which would be printed on the top silk screen. And Eagle needs to include T-place and T-names. But we also need to include the T silk screen layer which we just added for our jumper pins and that kind of stuff. So I'll just go on selecting the layers. Also add T values to it. I'll go all the way down to 121, which is the T silk, and I'll hit OK. And now you can see all your important data which you added in the top silk screen layer has been added, along with the designators, which are the names which come under the T names and the T values. So that's it for the top silk screen. Top solder mask. Again, we are not soldering anything on the top layer, so we can just delete this layer. Next up is top copper layer. We don't need that. Nothing is on the top layer for soldering. Bottom copper layer. This is the most important layer because that's where we did all our routing. And Eagle has to select the bottom layer, pads and vias. Next we have the bottom solder mask, bottom silk screen. Now there is one component on the bottom layer which is the fuse. For that, let's also include the bottom values, and if there is anything on the bottom silk screen, I don't remember adding that, but let's just add it. And bottom solder paste for the SMD component, which is the fuse. Next up, drills. Now there are two types of drills. One is the plated drills and other one is non-plated drills. Now non-plated drills are these mounting holes of size 3.1 mm which we added, and plated drills are all the connection points of your ICs, resistors, capacitors and whatnot. Let me quickly show you a difference between what a plated through hole looks like. So in a plated through hole, you have the copper conducting from one part of the PCB to the another layer of the PCB, and in a non-plated through hole you don't have any copper. So this is where your M3.1, like the 3.1 mm through hole for the mounting hole goes. So here you will be just inserting a bolt for securing the PCB, but here there needs to be an electrical connection. That's how it will look like. But since our PCB is only a single layer PCB, the plating will be just on the, let's say, the bottom layer, and it will be only limited to the bottom layer. There won't be any plating on the top layer. So that's the difference between plated and non-plated. So we have non-plated drills and you have plated drills, but this thing is also showing up in plated holes. I don't think so. We need to, yeah, we can just uncheck the holes. Includes non-plated drill holes. So this is just for displaying. So I don't think so. We need to worry about that. So there is more stuff like assembly, drawings, and legacy. In assembly, I believe you can add BOM, bill of materials. In drawings, you can add DXF, and legacy you can add your own legacy cam job, but we don't need that as of now. So we have added we have deleted the layers from the top layer, the top copper layer, and that kind of stuff which we never needed. Now these are all the Gerber files which will be generated by this cam job. Bottom solder mask, bottom copper layer, bottom seal screen, bottom solder paste. That's about it. It says export as zip. It should be fine, and these will be the names of all your Gerber files over here. So what I'm going to do next is to the bottom right and click on process job. Now this is my folder where I have my schematic and board files. You can easily ignore the audio files. The audio files are the audio because of which I'm recording this video. So I'm just gonna hit save. And it says job process successfully. I'm gonna click on open folder. These are all the revisions which we made, all the control S, the saves which we did, and these are your Gerber files. So I'm just gonna extract them, and here we go. These are all your Gerber files. Now there are lots of Gerber file viewers where you can easily view these Gerber files. There is one which is very let's say clean and simple and easy to use. So let me particularly show you. Yeah, well, I can do the same changes later, so I'm gonna just discard this and I'm gonna go to my desktop. So the name of the program is Gerb. What I'm gonna do is select all these files and drag them to this icon, and the Gerb loads with all the Gerber files. Now I'm just gonna switch off all these layers. These are all the Gerber files generated by the CAM processor. So let's just select them one by one and see how they look. So the first one is board outline. Here we go. This is what your board outline looks like. Then you have your bottom layer. This will be the copper on the bottom layer. Then we have bottom paste, which is one of the SMD components on the bottom layer. We have bottom seal screen. Then we have bottom solder mask. That's where your solder would be masked. And we have non-plated drills, plated drills, and we have the top seal screen. So as per this Gerber file, the manufacturer should have all the details to get it manufactured. Now the next step is to send the Gerber zip file to the manufacturer. Let's get started with that. Alright, so now since we have a zip file full of Gerber, we can just upload it on some PCB manufacturer's website like JLC PCB. Now this video is not particularly sponsored by JLC PCB, but I have used their services, and they do some really nice PCBs at ridiculously low prices. So yes, I do recommend JLC PCB. What you can do is add the dimensions of your PCB: 45 60 mm, number of PCBs 5, layers, it's only one layer board, and the total thickness of your PCB is 1.6 mm, and hit on quote now. Next, they ask you to upload your zip file full of Gerbers, and while they are processing that, we can discuss the rest of the options over here. One layer, these are the dimensions of your PCB. Then you have quantity, PCB thickness, which is 1.6 mm, PCB color. Yeah, here we go. It's a green color PCB. You can select all these colors, and the Gerber automatically detects, the Gerber processor on the website detects, yeah, it's a one layer board of so and so dimensions. Next, you have the surface finish. So there we go. You have a special offer of $4, and you can choose your shipping. But if you do a lead free surface finish, then the price goes up. Well, yeah, that's the price you pay to save the environment if your PCB needs, it's not properly recycled or something like that. And next option is copper weight. Now, what does 1 oz mean? 1 oz means 1 ounce, and 1 ounce of copper poured in a surface area of 1 square foot. That's what 1 oz means. But what does that mean in terms of PCB thickness? So if you see this website over here, PCB copper thickness, 1 ounce is 1.4 mils. That's the thickness of your copper layer. What's 1.4 mils in mm? It's 0.035 millimeters. These numbers look surprisingly, I think so, I've read some of these numbers over here. Yeah, you can go check in DRC, then you have layers. Oh yeah, there we go. The copper thickness is 0.035, and the core, which is the non-conducting part, is 1.5 mm. And I think so they rounded up to 1.6 mm. That's how it works. Coming back to the Chrome, yeah. Gold fingers, material tilts, panels, you can just keep these options as they are. Flying probe test and castellated holes are things like way out of bounds of this tutorial to discuss, but maybe you can cover them in upcoming tutorials. So that's it for JLC PCB. You can just add this to your cart and get it manufactured. All right, so the last step left is to generate a BOM. Well, BOM stands for Bill of Materials. It's basically a list of all these components which you have used on the PCB to design a PCB. So let's say you have to go to some market or go to a website like Farnell or Mauser or LCSC to buy all these components. It's good to have a proper list with all the manufacturer part numbers, so you know what all things you want to buy to complete your circuit. So how to do that? Probably the easiest things. You do file, export, and you to go to BOM. So these are all the components you have used. C1 is capacitor 1 with value 10 microfarads and that kind of stuff with description, and these are all the attributes. We can uncheck the attributes. Now it's a little bit cleaner, although there has to be one more column which says MPN, manufacturer part number, which we can add later. Now this BOM is listing all the parts. Well, that's not how generally it is done and recommended. So what we do is you click the radio button on values right now. So it has grouped the similar components, and it has given us a quantity columns in multiples of the same component. And I prefer a comma separated values file. What you can do is save, and I can just save the CSV file in the same location. You can then open the CSV file in Excel, but before going to Excel, I'll recommend you open it something like Notepad++. Now this is a CSV file, but the delimiter is a semicolon. Let's just copy the whole thing and open Excel. Here we go. We have a blank Excel sheet over here. What I'm going to do is paste the whole thing in one column. It says the data you're pasting is in the same size as your selection. Do you want to paste anyway? I'll just click OK. Now I need to separate this text into multiple columns. So I'm going to do data and I'm going to do text to columns. Yeah, so I'm going to select delimited characters such as commas or tabs separated each field. I'm going to do next. Now the delimiter over here is a semicolon and not a tab, so I'm just going to click semicolon, and here we go. It has separated all the single column into multiple columns. I'm going to do next, and you can just finish it off over here. Now here we go. Here you have your bill of materials with description. What I'll also recommend adding is an MPN column, which stands for manufacturer's part number, and the Atmega IC, which we plan to use. The exact manufacturer part number is 328P-PU. Also, where is the fuse which we used? Yep, this is the one, and this is also the exact manufacturer's part number. Rest of the components are like pretty generic. You can also find them locally. You don't need to buy them online. So that's about it with your BOM. Now if you want to buy some cheap components, cheap good quality components online, I'll also recommend LCSC. And if you also want to look up the resetable polyfuse, or let's say the Atmega 328P, let's look that one up. Oh yeah, I've already searched that. It's my search history. And they have the whole IC over here at some really good price. This is the resetable polyfuse. That's what it looks like. So you can that's pretty cheap, like just 12 cents for one, and they do sell loose stock. So that's about it for this tutorial. I'll be adding all the files which we worked on: the schematic file, the board file, the Gerber files, the BOM file, and also the PDFs of the PCB and the schematic in one zip folder. Or I'll probably paste a link to my GitHub in the description, where you can find everything right up until from the first video till this video. So that's about it for this video, and probably in the next upcoming videos we'll be doing some pretty more complex stuff, like going multi-layer, 2 layers, maybe 4 layers as well. So hope to see you then. Goodbye.